The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
2 ints. I have also func 1, right, with the float element, for example. The system will pick out which one of those func 1 functions it's going to pick based upon the signature of the call, right? So you're in main and you call, right? If you send the name with 2 integers, which one are we going to call of the 2? The top one. If we send the call with a name with 1 being a float, 1 being int, it's going to call which one? The bottom one. So that's what we're kind of talking about here. We'll see this a lot more as we continue our journey here with classes, right, and derived classes. But that's essentially what this is talking about, this idea of polymorphism. So, and literally, these are 2 the same name, right, functions, methods. And in one case, you get the output of card, and in the other case, you get the value of the 3 parameters or members for the class, right? Positional card has 3, rank, suit, and face up. Okay. Does that make sense? Questions? All right. So again, and we've talked about encapsulation, we've talked about reuse, we've talked about polymorphism. These are sort of the core principles. And especially in the case of stuff like this, where you can reuse methods, right? And in derived class situation, extend them, overwrite the method, right? This gives you a lot more opportunity with the class for reuse. Okay. So, creating modules. Right. We're going to get into this coming up here soon, right? More, but the idea of creating, using, and then sharing these modules, right? We can do. I mean, in terms of reuse. The card, deck, and hand classes that we crafted, right, we can use those for any kind of game, any kind of card game, right? There's nothing specific in there that talks about the game, okay? Those are base classes, okay, if you think about it. Now, deck obviously is a derived class of hand, right, but they're foundational concepts, right? Every game that plays cards has a deck. Every game that you have that plays cards, there's a hand, right? The person either holds the cards or has them in front of them, right? You have that representation. Right? Then you have specific versions of those for specific games, okay? And that's what we're talking about here, really. So in this particular case, we have a player, right? So we could create a module for the player class, right? And that would contain, for example, your name and perhaps your overall score. Right? Now, we could make player, for example, in this particular case, you could make player a derived class of hand as well. Right? And what would that afford you then? What would that allow you to do?
Assign all the members from class into one for player.
Hand class.
The hand
right?
class.
Right, the hand class shows you what that player has. All right, and then you could look at the individual elements in that list and develop your sum or your score value here. Right? So the only thing that, for example, this might have in it is that little computation that takes the value, the ranks of the cards, and adds them together. And then gives them the value, assigns the value to score. So, does that make sense? Again, this is something for reuse purposes, okay? But the blackjack version allows you to look at that. It's a small problem. 2 cards, 3 cards, something like this. All right, so here's a couple more things that you can look at with regard to reuse and functionality, right? And we started to look at this a little bit also earlier, right? If you look at these 2 functions here, ask yes, no, or ask number, right? I think did we actually look at ask yes, no before already?
No.
I think we did display or question or
You
something. It was
mentioned
very
it.
something like this, right?
Yeah.
What can you tell me about that ask yes, no function up there?
It is a derived class of question. Oh well, no.
No.
It's a method of
Nope. Nope. It's just a regular old
function.
function. It's not part of a class. Right, if it were part of a class, you'd see that indented underneath some sort of a class. Right? This is just a standalone function. Right? So having said all of that, what do we have now? What's the neat part about this?
The fact that it can be reused.
It's reused. What is question?
Could be anything.
Anything.
Any kind of Boolean question, right? True, false kind of question. You can send it, done. Right? How about the next one? This one's even more interesting.
So it can be used for any number when you're given a low value and a high value.
Any kind of a range question,
Right.
right? Low and high range. Send me the values that you'd like in the question. Right? Pick a number between 1 and 10, 1 and 20, 20 and 40, right? Nice reusable code. This is where you need to get to, folks. You need to get to functions like this. Okay? Questions? Remember, there's no such thing as raw input in a 3-dot Python. It's just called what? Straight input. Questions? Not to worry about that. Importing modules, right? So let's say you have a file that has all those kinds of functions in it, right? A module that has that in it. You could just use a straight import just like that, as long as it's in the same directory as your source code. Does that make sense? Code that has your main in it.
So kind of like what we did with importing like text files?
Yep.
Same thing?
Yep. Except in this case, you'd be importing programming. So, okay. Questions?
And so where it says games, that's the name of the file or the name of the Python file, right?
It's the name of the Python file that, for example, in this case, your game is in.
Right.
Whatever has your specific.
And then random is the method name.
No, random is the random library.
Oh.
It's
okay.
This is just multiple code files that you're going to import in. Yes.
So technically you could have like all of your base files like in one.
That's where we're going.
And
yes.
then you would put all your details in your like actual main function.
Well, you would have like your class definition in one
Yeah.
implementation, and then your main in another file, and then maybe some reusable functions that you want to have. Glue your code together much quicker.
And if they're not in the same directory, then you have to specifically define.
Put the hierarchy in place as well. So, in other words, C:\\/ blah 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 where that file exists. So using imported functions, right? Games.askNumber, games.player, name and score. Right? That's just illustrations of exactly that. So. All right, so let's look at this. Actually, let's do this first. Here is sort of the family tree for the blackjack, reusing the card, hand, and deck class that we have built so far, right? So, for example, you could have a games module that has card, hand, and deck in it, and you can create a derived class of blackjack card, called blackjack card. And that would inherit all of the stuff we've done, right? And that would include the printable and positionable card, okay, in the blackjack card. And it would have all of that capability. Does that make sense? Yes? We could literally have a cards module that has all of those pieces in it. And similarly with hand, right? We could actually have hand in that module too, and for that matter, deck, right? They're individual classes, but there's specifics around a derived class for blackjack. So in the case of card, you'd want the ability to flip and so forth, right? In the case of hand, right, you can set the deal method to, instead of dealing minimum 1, dealing minimum 2 cards. Right? There's some things you can do to set that. Okay. In the case of deck, blackjack deck, let's see, is there anything unique there that would be different? Not really. Well, if you were to, this would be probably a direct. You could probably get away with using this deck because it's deal populate and shuffle. Right? So there's not a whole lot of difference there. But in this case, they're already showing you the 2 additional derived classes for blackjack against hand. As I said, this player could be a derived class of hand. So you would get, from hand, you'd get the cards in the person's hand as well as the name and the current score. And in the case of the dealer, you would have that as well, but in the case of the dealer, there's one more extra stipulation. There's a mandatory take card, take a hit at either 16 or 17. Right? That is not necessarily in place for the player. Does that make sense?
How do you play black? You gotta get to 21, right?
Yes.
You're
The goal is, the objective is to get to 21 or as close as you can going over.
Right, and you could take a card, and then if you go over 21, then you're lost.
And that bust or take a card concept could be put in here under player as methods. Just check the score.
And then each, okay. Does suit matter in blackjack? If you have a higher suit?
Not really, it's the rank.
Okay.
It's the rank.
Okay. Yeah.
You also
Unless you
usually
see-
use multiple decks when you're playing anyway, so it doesn't really matter what.
Yeah. Typically. Like if you're in Vegas or some
They
casino.
have like 4
Right.
decks together, so it doesn't really matter.
Right. Anyway, you could do something like this for any card game. Right? Just to have the specifics. The part that comes into sort of a little bit of an original thing would be this blackjack game. Right? And that would be just managing who's first, who's second, right? And then keeping track of who's in or who's busted. Right? So, questions? I think you get the idea of the power of using this derived class stuff. So. And we will be using it, and again, here's the pseudocode or sort of the algorithm for blackjack. Right? And we've looked at something like this already once, and the idea was that you could use this, every line in here, for example, could be a separate callable function, right, from main. Same kind of thing here, except in the case of player would be like blackjack player or dealer. Okay. I think if you walk through that, you'll understand what I'm talking about. Questions? Chapter 9 questions. We're at the end of the external stuff. Going once. Questions on this? Going twice. Everybody got it? We will come back. All right. Let's go to the part that everybody wants to get to. Ready? back to the textbook. Chapter 17, my friends. Chapter 17. Round of applause. You've arrived. All right, so we're going back to invent with Python. Let's go to this guy here. And we're going to this. Read online for free. I'm going to download the source code. And show in folder. Extract everything. And we're going to Pygames Hello World. Put on your seatbelts, my friends. We are about to go to light speed. Here's our code.
You said that. Okay.
Does it look exciting?
Yes.
Alrighty? So, this is what you should see when you run.
It's broken.
Nah. That's what you should see. So who sees that? You got it. Got it? Got it. Got it, got it. Who doesn't see that?
Pygames Hello World at the bottom.
Yeah,
Right there.
Pygames
Fourth
Hello
one
World.
up.
Okay.
You guys get it? Pygames Hello World. Bottom of the directory. Ooh. Isn't that nice? Why do you think that's happening? Well, can't find Pygames. What's that mean? It's not installed. So go back to the class site and install it. Run. Edit with idle.
I broke it.
Run.
I broke it.
You're good. Go. And you're trying to install it. Didn't work.
Why does mine say that?
Yeah. Reinstall.
I don't know.
You may have to drop Python too. A lot of times that ends up happening. I'll wait another minute or two. Those of you that have it, take a look at the code. It's very exciting. Still not. Are you running 3.6 or are you running 3.2.5?
I think it was 3, 2, 3, 1.
Push on the start button. Oh, this is, no, you're running 3.6.
Oh,
Oh, look at that, look at that.
That's why it's not.
It's like, oh.
I'm going to drop your instance of Python.
oh.
Go ahead and run that. All right, my friends. Everybody got it running? No? You're running 3-6 playtime. 3-2-5. No. Just drop down and hit the start button. Wait a minute. 3-2. There we go. That'll go. Now, run that code.
Watch yourself. Run.
Not whack.
Run that code. Oh shit.
Go back to the consent list. Okay, is it running now? Hello?
You.
All right, 3-2-5, my friends. 1.92 and 3-2-5 work nicely together. That's why I have them on the class side. Okay. All right, so welcome to Pi Games. It's one of the old school, I hate to call it a game engine, but that's what they call it, a game engine. But in reality, if you look at this, look at this guy right here. What do you see? Start at the top. What's the first couple lines telling you?
We are importing from Pygame, and we are importing all of the methods from locals.
We're
Local
bringing in
class.
Pygame at large.
Yeah.
Import asterisk, okay? Not a single function or something. We're bringing the whole thing in, okay? What's the next thing you see underneath setup Pygame? Pygame dot. Pygame's been around so long, it doesn't even have an underscore on it. What is that first line? What are we doing?
Calling the constructor.
We're calling it a constructor because Pygame is a giant class. It is a giant class. It has several hundred members and several thousand methods. So here's what I want you to do. We just ran that code. I want you to try running the code again. Comment out the pygame.init
So not gonna work.
and run the code again. What do you see?
A blank box.
A blank
Black
screen.
box.
It crashed.
Wonderful.
Computer.
That means in order for any of this stuff to happen, we need to have our instance of Pygame out there. And we're going to do exactly what we've been doing prior to this, right, with the blackjack game. We're going to be calling methods and members, working with that in that confine to be able to go ahead and put stuff up on the screen for yourself. Okay? So, we've created our instance of Pygame with all of this wonderful stuff. What is Windows Surface, my friends? You should be able to tell me.
It's a very.
Isn't it setting up the dimensions of the box that it's going to display?
You just spent the last half hour talking in terms of technical stuff with regard to objects. I'm going to ask the same question one more time. What is Windows Surface?
It's an assignment thing.
I'll go one more time.
A very.
3 times better be a charm. What is Windows Surface? It's a local instance of pygame.display.set mode. .display.set mode. Display is an entire subclass in Pygame that has a whole bunch of methods attached to it, one of which is called set mode. So why don't you go out, you're the Google generation, go out there and look it up. Set mode.display. What's it say?
Initialize a window or screen for display.
Okay. Right? Pygame.org is your next new friend. All documentation, all of the support material is in there. Okay? So, once again, what is Windows Surface?
A local instance.
It's the local instance, right? That is defined by 500 by 400, comma, 0, comma, 32. What does that mean?
Well, 500 by 400 pixels.
Okay, you said something else interesting. What is a pixel?
It's a little dot on the screen.
Marvelous. Great answer. Come on, you tech heads. What is a pixel? You knew better than that. This is where I get the ruler
The
out.
smallest unit of a digital image or graphic that can be displayed and represented.
You can read. Okay, it's just a very, very small thing, and that's the unit, basically the unit of measure on a screen. Okay. Let's talk in terms of a little geometry here. When I say the term origin, what does that mean to you?
Oh, that is 0, 0.
Okay. So where's that at? Or what are we talking about here?
The center of the planes.
Okay. So in the old days, probably in a previous lifetime, for all of you younger people here, when the teacher in geometry said, where's the origin, where would that be? Right here, right? 0, 0. Right? First quadrant, second quadrant, third quadrant, fourth quadrant, right? I got bad news for you. They were lying. In this space, the origin is right here. 0, 0 is upper left-hand corner. And I'm kidding. They weren't lying to you. This is, in the real math world, this is still true. Right? But we're not in the real math world. We're in the graphics world now. And 0, 0 refers to upper left-hand corner, x is 0, y is 0. Okay? So when they say 500 by 400, what they're actually saying is 500 pixels this way, 400 pixels this way. Okay? So, this, my friends, is your Windows Surface right here. This guy right here. That's your game world now. That's where you are, and I hate to use the term, but it's truly true, you are God, right? You are God in that little world. You define the physics that go on in that little world, anything that goes on in that 500 by 400 space, right? So if you want to have the graphic, sort of the, what's the cartoon, the guy, it's a squirrel who lives underwater, SpongeBob or something like this, right? Where the squirrel has the helmet on, and he actually has fire underwater, right? That is, whoever the designer is, that's their world. They make the physics happen there. Does that make sense? So things that are completely unnatural in the real world, you can make happen in there, right? You are the responsible party. Okay, does that make sense? So what's the 032 for?
Is the 32, is that where we're beginning on the Y? Like, are we not beginning at
No.
origin? We're beginning at 032?
Guessing is not good for you.
Oh, okay.
I would go back and take a look at that definition.
Okay.
Go to python.org or pygame.org and look.
I'll have display equals 0.
Okay. So 32, what does that 32 represent? 32-bit, maybe? What do we got? Tell you what, we'll leave that go. You can go out and look at that in your own time. Okay? So anything that we do now within this set of code that is going to the output screen, this guy here, right? So we have our shell, our code window, and then our output screen. Okay? Anything that's under the control of Pygame will go to this window here. Anything that Python is responsible for will be in the shell, right, with regard to output. Okay. So what's the next window talking to? Or the next line of code?
It's sending a string.
Pygame.display.set caption. Look. I mean, you can think of pygame.org as the documentation for the Pygame class. Okay. What's it say?
Set the current window caption.
Yes. So that would refer to this right here. Right, that little graphic piece in the hello world text. Right. So that sets that up. So we've got our window now, right? We've even got our caption defined. Then what's the next block of stuff up there? And you should know all of this, because we've used these many times already. What are all these things? All they're variables, but they're all uppercase. What do we call them?
Constants.
Constants. Right. Constants. So rather than worrying about the RGB colors here, right, we're just saying, I'm just going to say black. It's uppercase, right? So that means it's a constant. It's global at this point. And we're saying black is equal to this. So what is that? We know what those are too. What is something that has parentheses on it like that? A tuple. What do we know about a tuple? They don't change, right? So we got this all set. Black, white, red, green, blue. If I want to talk in terms of colors for my stuff, I just refer to these constants and I'm all set. Okay? Questions? So that's your color palette currently that they want to use. So if you look up on that screen, in this guy here, in our little window surface, you'll notice that those are the colors that are being used here. Right? So if I want to create a new color, right, I would go out and figure out what my RGB values are and set another uppercase string like that. You know, George's color, I don't know, whatever.
Teal.
And you could refer to that in your code. That's the nice thing. Instead of having to worry about, now what's the RGB for purple? I don't remember. Okay. All you need is the constant. It's much easier to remember. Okay. Moving on. What is this guy here?
It's an instance.
Okay, it's an instance,
Yep.
right? Pygame.font, that's this font, none, comma 48. We're setting up the standard for fonts, the basic font standard in our code for this world here. Okay? size 48, folks. Okay, no special italics or any of that kind of stuff, right? Again, you can go out and look up all of these things, right? How they work and what's happening. As a matter of fact, I would highly recommend your next next adventure in reading be reading over the pygame.org library to see what's out there. There's a ton of great stuff out there, including lots of nice examples. Okay? Okay, moving down, and here's where it's going to start getting interesting. What's the next line?
Text equals basic font and render.
So, this is basic font, and we're calling the render method from basic font, and we're sending it a string, a boolean, and 2 colors. Go out and check it out. What's happening? What's text equal basic font dot render?
Okay. So are we calling the render method of the instance basic font, right?
Mhm.
Which is gonna draw the hello world for us. So it's gonna
Okay.
insert that string, and then it's gonna give the 2 colors that we picked, the
Mhm.
background and the color of the text,
Yes.
and the highlight.
Yes.
Okay.
Alright. We're calling the dot render method for this guy here. And this whole thing will be called text. So we're going to be dealing with this text thing a little bit. Okay? Now, go out and look at this. Get underscore rect. What does that mean?
So
We're using
determining
div.
the size and offset of the rendered text.
Okay. Okay, it's the final dimensions of origins in pixels, right? Using the optional size, returns. Okay. So we are setting ourselves up for this text rect. And then what we're saying is right here, what? What is center X and center Y? What's it saying to us? Center X and center Y.
Well, I guess it's gonna be wrong.
All you can do is guess.
I mean, like X and Y lend to coordinates.
Okay.
So I would think that it would be saying like, so you're returning text rect and that's where it's like replacing it.
You're in the neighborhood. Okay? Yes, we're talking to the X and we're talking to the Y. Right?
When does rect get defined? What is that?
When does rect get defined?
Yeah. I don't understand get wrecked. I don't understand that
Get
one.
wrecked is take a good look at it. So text dot get wrecked. Get wrecked is a structure that's part of the class. Right? We're going to be dealing in rectangles. Right? We're going to be dealing in rectangles. All right?
So and get it's like the get function that we worked with earlier.
Yeah.
It was
Give me the values.
Okay.
Right? But center X, center Y literally are the center points based upon our definition of Windows surface. So what would those values be approximately if it's 250 or if it's 500 by 400?
So it'd be
250,
250 by
250?
200.
250 by 200.
Oh.
Right? It's not an actual square per se. It looks like it, but it's not. Right? So roughly ballpark 250 by 200, right? And that's where it's going to put that text. Right? That is our new center location of these guys right here. So for our text rect object, right, we're going to define it at that location. All right? So, questions up to there? Got a few things going on here, don't we? You understand the emphasis on classes and objects and methods and all of that kind of business, because we're going to employ them big time now, right? All of the heavy lifting graphic stuff will be done by games. And we're just going to talk to it, right?
That's nice.
It's beautiful. It's a beautiful
Makes
thing.
things a little easier.
What's that?
So I think it makes things a teensy bit easier.
I don't know if I'd say that. It's a pretty complex tool. All right,
I mean, it's easier than setting all of it up ourselves.
but you will be doing that shortly. All right, what's happening here?
So the the fill method of Windows Surface class is being given the parameter white, which is the color that we defined earlier as a constant.
And it's going to?
Well, if I look it up.
It's going to fill the box, fill the Windows surface. So here's what I want you to do. Change the color. Create a new RGB color, make it a constant, and use that color to fill the box. I'll give you a couple minutes.
Oh my.
Oh, wait.
Yeah?
I'm so excited.
Freaking sucks. Where'd Homegirl go? She just left. She was like, I'm out of here.
Yeah, she stepped out right when we started.
She what?
I think so. I don't see her stuff there. No.
is confusing, man.
Yay! I made it purple. I feel so accomplished. You okay?
No, I'm not.
Don't hurt yourself.
My body is broken down. Carrying heavy shit.
I was about to say, I think the military does that to you.
Yeah.
And,
Yeah, that works.
gee, imagine that.
I did it.
You know what you're doing. Go figure.
Questions? Up to there. Isn't this exciting? Wait till things start moving on the screen. Then we're really going to see some excitement.
Ooh.
Okay, so we've gotten up to the fill. And now, let's go a little further. What's happening? Pygame.draw.polygon, Windows surface green, blah, 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 blah. What's happening here?
I mean,
Which one?
it's telling it how to display the shape polygon onto
Well,
the Windows surface.
let's start by going out and looking at what that means. What does polygon mean? Surface green, blah, blah, blah. What is 146,029,106, 236, 277, et cetera,
They're
et cetera.
coordinates for the point, for each point on the polygon.
Okay. Okay. We're getting there. Right?
It's
The
gonna-
vertices of the polygon, my friend.
Vertices.
Right? In this particular case, how many points are there?
5.
5. Somebody said 5. Let's see if we can figure out which object this is, right? So 1 pair, 2, 3, 4, 5. It says green on Windows surface draw. I'm going to guess that this is that guy. Okay? All right. How about the next 3?
The next one would be the circle in the upper portion.
What, the draw line?
Oh no. Sorry, I was looking at the sheet.
It's gonna be the Z.
It's the Z.
Yeah.
Okay, so we've got vertices again.
Mm-hmm.
What else do we have?
Thickness?
That counts.
That's what the 4 is.
Thickness of the line. So drawing lines. And the colors are, color of the lines is
Blue.
blue. Right. Imagine that. How about the next one? Draw a circle.
That one is the circle I mentioned before.
Okay, so it's 300 by 50. So that's the center. Right? We got a 20 and a 0. What the heck does that mean? What's that? The radius? Okay. Next one is the ellipse. Which one is the ellipse out there? Is it this guy here? Okay. Not bad, not bad.
Okay, that makes sense.
All right.
I'm sorry, can we go over 20? I was super confused because I was looking at the draw lines of the Z. And
Okay.
I was following along wrong. 20 on the circle is
The radius.
the radius. Okay. And
You can look all these up.
okay, great.
0 is probably thickness of the line. Maybe. I don't know. Ellipse would be the 300, 250, 40, 80. I'm not quite sure what that represents. Right? But, you know, thickness of the line, maybe 1.
That's the
Yes, sir.
How come we state the thickness of the line for both the circle and the windows, and the ellipse, but we don't state it for that center Z line that we do, because we got 4 on top, 4 on bottom, but there is no line.
Why do you
thickness.
think?
Does it automatically go to a default like 0?
Possibly.
So if we,
I would look that up. Right. That would seem to make sense.
does that mean we could take 0 out of circle and be the
Do
exact same?
yourself a favor.
Mhm.
The second draw line,
Yeah.
make it 7 at the end, comma 7. See what it does. Right.
Oh my god.
Okay.
And what does it do?
Makes it big.
Makes it big.
Is that correct?
Okay. What do you notice though? Is there a big difference between 7 and 4? Not terribly.
No.
3, what did you guys call them? Let's try that one. Right? It's getting interesting. What do we always say? Right? Make a change, try it out, see what happens. Have some sort of hypothesis about what you expect to see. Right? Questions up and through ellipse. I'm not quite sure what the only 4 numbers represents for the ellipse.
It's I think it's the A squared value and B squared value.
For the ellipse,
Yeah.
this guy here.
Yeah. So like 250 is the A squared value and 80 would be the B squared value
It's possible.
because it's equal to 1, so that'd be the only. There's no vertical. I don't know, whatever.
I would look it up.
Yeah.
Read up on it. Right? We'll be living with geometry for a while. Geometric shapes, my friends. That's where it's at. Okay. So now that we've gotten through that part, let's draw the text background rectangle onto the surface. So this next line here is very interesting. This guy right here. What's going on there? What is that guy doing?
Okay. So it's drawing a rectangle onto the window surface. It's giving it the color red, and then it's defining the lengths of the sides, like the length, width, and height.
I don't know. We haven't seen text rect in a while. Where's text rect? What's text rect say to us?
That is specifically doing the rectangle, or
Right, so center X, center Y come to mind.
yeah.
So when we talk in terms of text rect dot left minus 20, and text rect dot top minus 20, and so forth.
It's defining the dimensions of the new rectangle based on the dimensions of the original text rect. So it'd be like whatever center Y was, but 20 to like the left, 20 pixels to the
So get used to this scenario here.
Mm-hmm.
Right? So we have the first number is the left value, second number is the top value, third number is the width overall of the object, and the fourth number is the height overall of the object. Right? So those left and right values, right, dictate the X and Y space for the new rectangle that we're building. By the way, it's red. Right? So it's this guy around the hello world. This guy here. Remember the old one was blue and white, blue background, white text. Right? So we're resetting it, creating a new rectangle, draw dot rect, window surface, comma red, with those specifics around our text rect object. These are now what's called relative coordinates to a certain extent. Right? They're relative to the current location of that object in space. Now, we're only doing 2D. That's all we're going to work on this semester. I think that's plenty to fool around with. Right? 3D would be very similar, other than the fact that you would have a depth coordinate that goes along with it. Right? And origin would be an upper left-hand corner still. Okay. So, this is a relative rectangle that we're putting together. What's the beauty of this idea, right? And why is this sort of a critical thing to have a hand on?
You can make graphics.
What's that?
I mean, like, it's all about how to, like, make and display graphics on your screen.
Well, it has to do with how to display something, right? What if I were to tell you I'm going to pick this thing up and I'm going to drop it into another kind of display, like a cell phone display or a tablet display? Right? What if I were to tell you that the sizes and values for those different displays is stored in a certain location, and the device, we were able to tap into that on the device by using relative information? We can scale to any kind of display, right? Rather than saying 500 by 400, we simply get those values from the device itself. You get my point here?
So instead of, like, for example, like text rect, you could have like something that symbolizes the display and just put stuff around that.
You don't use any actual values at all. Everything's relative.
Right. So when you first create the instance window surface, you have to pull that information from the device and then input it as your tuple.
Yeah, you don't input anything. The system, you pull it right from the location.
Right, like the system will take it and use it as an argument inside of set mode.
Right. And then everything else is relative. What's the beauty of that plan? Especially thinking in terms of all this new knowledge you now have about classes.
You can essentially make it however you want to fit like what you're building it for. So it's like
There is no building it for. It's one size fits all. Write the code once, and that code will scale appropriately for any kind of display, right? Given the fact that the device talks in the same terms as your code expects, right? So, as you all know, Android and iOS don't talk very nice to each other, right? So there's a little bit of a problem there. But any kind of Android-based device, you can get the information from the same location. Any iOS device, you can get that information from a specific location on the device, right? Most of that is called out in the specifications for the device. Right? But my point is, write the code once and reuse it everywhere. You only have to maintain one set of code. Now, let's talk about it in terms of something else. I'm a game company. Would I want to put this kind of code into my game itself? Or would I want to have this just as a separate little thing that literally calls those objects like Windows Surface and so forth and so on?
Second option.
You want to call it?
Second option, right? Because I don't want to have to rewrite my code every time my platform changes, or they come up with a new resolution for a device.
you just want to edit this specific part.
Unplug one, plug the other one in, have a nice day. Package it, right? Saran wrap it, Mario Party 23, ready for sale for Christmas. And wait for all of you kind people to send us money. Welcome to the game world. This is how they do it. Right? They create a one-size-fits-all piece. Then they just literally unplug and plug in the new display resolution requirements and have a nice day. Nintendo is great at this. They do a marvelous job. Now does it make sense? Starting to make sense? You'll see more about what I'm talking about as we continue on. Right now, all of those hard values are good because we can relate to them directly. Okay? But what you want is something that will scale properly based upon the device. You won't have to change anything. Questions at this point? There'll be plenty more, don't worry. All right, so we got to this relative box. So now we're starting to deal in terms of a rectangle. And our rectangles are going to have 4 values. Left value is the left side. The second value is the top, how far down from the top, the actual width, and the actual height of the image. Okay, so one could think of it as left, top, right, bottom. Okay, but the last 2 values are going to be based upon where the starting point is for the first 2. Okay, so. But we will be looking at this rectangle concept quite a bit. Okay. So, questions up to there? Let's go on to the next one. Gets even more interesting. So what's happening here? What's that all about? What are they doing there? What are they doing to the Windows surface? Go ahead.
Taking the dimensions of a pixel from hiding and displaying it all across what you have set for Windows surface.
Okay, so we have this object called pygame.pixelArray Windows surface. And we're assigning it to something called pixArray. So what are we essentially doing to our Windows surface here? We're converting the whole thing to a 2-dimensional array. We're saying, take my current Windows surface that I have defined and send that to pixelArray. PixelArray will, at the pixel level, right, take that structure, right, and what they want to use, call that pixArray, because they want to deal at the pixel level. So the very next line says pixArray, which is this current guy, at 480, 380, I want you to put this there. So let's look at our Windows surface for a second and see if we can find our little black dot. Does anybody see it? It's this guy right there. Look at your window. Does everybody see it?
Mm-hmm.
It's that one little dot. That's the size of a pixel. Do yourself a favor, go into that code and either go increase this one by 1 or this one by 1 and put about 5 dots, 5 equals blacks in there, right? So 481, 380 equal black, 482, 380 equal black, or modify the 380 value just so you can see it better.
I don't see it.
Do you see it happening?
This little thing that's a tiny.
That's a.
That's 1 pixel.
Oh, that thing right there.
There you go.
So these are the coordinates.
You're just warming up. It looks like a line, but at least you can see it.
Yeah.
Right?
So
You're
what
able
you
to
use-
grab those locations in the 2D array called pixel array. Right? We're exercising the pixel array method. from Pi games. Does everybody see that? Okay. Then let's go down to this line. This is where it gets interesting. We're doing a blit. So Windows Surface.blit text, comma text rect. So what's that doing? What is a blit? It's an old concept. We use it occasionally anymore for text. What is the blit doing for us or to us?
To blit. Draw one image.
What are we doing?
It's drawing an image onto another.
Okay.
It's taking
So what is our text rect?
text.
Text rect is a rectangle.
Yep.
We're saying draw the text, stick it on top of our rectangle structure. That's what blitting does. It literally attaches to that structure. We're sticking it on there. Okay?
Do they move together?
And they will move together later. Okay? So just a quick thing. And then pygame.display.update. What exactly does that mean? Here's what I'd like you to do. Comment the line out and run the code again.
It refreshes the display.
What happens?
Nothing.
Nothing. What do we get again? Blank screen? Come to mind?
Mm-hmm.
So what do you think the dot update does?
It refreshes the display.
Right. So everything we've been doing up till now goes to what's called the back buffer. Right? The back buffer is just a storage or holding piece behind the scenes. And when it executes the update, it takes what's in that buffer and dumps it to the screen. Right? Clears out the buffer and allows you to continue. Does that make sense? So everything we've done up to now, all this stuff, is literally being communicated to a buffer space. Okay, that's defined as our Windows surface. And when you hit update, what it does is it literally dumps that buffer right to the output. Okay? So what do you think happens when we start talking in terms of things like animation or collision or any of that kind of stuff? Anything that's moving?
The display will just update each every time it moves. It's just updating a new picture.
Well, you're sending it to the back buffer every time on a big loop,
Yeah.
and then on the update, it dumps it to the screen and starts over again. Starts dumping stuff to the buffer, dumps it to the display, and comes back. Right?
And keeps doing
It's
that.
this
like-
it's this method. Right? Everybody got me here? Load the buffer, dump. Load the buffer, dump. That's what's happening. Right?
So it's
That's
kind of
the
like those
process.
old, like flip books for animation.
Yeah,
Each one is a new
exactly. Yeah.
It's updating like every frame.
What's that?
It's updating every frame.
It dumps the entire screen, each frame. Right? Now,
So when it talks about like frames per second, it's like how fast it can dump.
frames per second. Frames per second. Right? So what's the typical human frames per second?
20 or isn't it like 20 something FPS?
You're in the neighborhood. About 25? About 25, 26 is your typical rate of refresh capability, right? So when they say 60,
It's supposed to be the best. On the,
it's refreshing that screen faster than what? Faster than we can see it happen. Right? So it can seem very smooth. Right? It can. Doesn't necessarily happen. Right? Load the buffer, dump it. Load the buffer, dump it. Load the buffer, dump it. Okay. Questions up to there? So right now we just loaded up the buffer one time Updated once, goes to the screen. Okay. Questions so far?
What is bit depth?
Where do you see bit depth?
Well, that's part of that's part of the it's one of the arguments for Pygame display set mode.
Okay.
It was the 32.
Right, 32-bit.
32-bit depth.
You're capable of displaying at 32-bit addressability.
Okay.
Okay.
So,
You can take an awfully large thing and use that. Right? 32-bit size. Addressability. 32. 32. Okay. Anyway, you can look up more of this stuff. We will be living in this space for the remainder of the semester. Right? So far, nothing's moving. We're able to sort of execute some simple geometric shapes. Okay? I would spend some time looking at this. Right? You were able to create a new color, right? Use it for the fill, right? And seemed to work all right. So Pygames is this giant object library that we create an instance of. We're bringing it in, taking advantage of it. We're using it. We don't know how it's doing it behind the scenes. None of these functions. We just know, here's what I need to make this method work. Does that make sense to everybody? And it's going to return something or not return something. We don't know. In some cases, they're void functions. In some cases, they're functions that return a value or more than one value. Okay? So I'm going to stop here. We'll come back. Right? So you have your little window open. This window, right? Let me bring this window back up. Okay. So, when you look at this window, look at this right here. I want you to click this red X up in the right-hand corner. Right? Click on that guy. What color is that X when you click on it in the box?
red.
Red. It's the red X. Everybody calls it the red X. And what happens when you click that?
It closes it.
Closes the window. That's what this is talking about right there. Right? While true, which is always going to be true, right? For event in Pygame.event, surprise, surprise, this is an event-driven thing. Event-driven object. As things happen in the game, everything that you do is an event. Okay? So we're going to constantly be monitoring the event buffer to determine what's going to happen next in your code. Okay? But we'll come back to that. All right. Questions, comments? Are we having fun yet? We're finally into the graphic space. I would spend some time with this. So when we get back together on Thursday, right, we are able to continue on. We got a lot of stuff to cover yet.
Okay. What PowerPoints are we going over Thursday?
None.
Oh.
We're in the textbook again.
Oh, okay, we're going back to the okay.
Chapter 17.
We're working with this.
Going forward, we will be living in the textbook. Then we'll be looking at some specific games.
Okay. So we should look at chapter 17 and 18 probably.
Yeah. Week 10, my friends. Week 10.
Yeah.
Good times are here. This is the part everybody wanted to see. All right. If you have questions, stick around. If not, we will talk on Thursday.
Good luck with today's lesson.